Welcome to a new stream. It's been a little bit. Why is the music louder on this side than on this side? That's never good. We'll see. We'll see what happens. Hey, how are you all doing? Who's here? There's 20 people here. We're a bit early. But we're doing the pre-stream, and then we're getting right into this guy. It's actually quite heavy. We're gonna have some fun today. It's pretty loud when it's silent. Wait, you can't hear me? Can you hear me? Hello? Oh, hey Yako! And Philip is here, that's nice. You were afraid you had to work, Philip? Did you finish on time? Or are you just, you know, watching me in the boss's time? Okay, the music is a bit loud now, isn't it? Let's tone that down. There we go. So we upgraded right before the stream to OBS 2902. It was in 28 before. That's always the best decision. Upgrade right before going live. I mean, what else do you do, right? You have to test it somehow. So far we're seeing 0 dropped frames, so that's good. Ah, okay, yeah, I had to turn the music down. It'll still duck down when I'm talking, but there'll be a little bit of background music when I'm not talking. I like that myself, so. Oh, you will start working at 11:30. Damn, okay. What? That can't be a single crimper. I believe it is. I secretly already performed surgery on it. Oh, and I didn't... hold on. I didn't obfuscate the address. So let's do that real quick. Off screen. It literally came in today. And I was like, okay, I didn't know what to stream about. Now I do. And after this, because I don't think it'll take too long, we might take a look at a secret and actually try repairing the secret. Because the secret is broken. It was working great. Then I broke it. So, who knows what that is? What's that about? Need a vise to operate it or a gorilla grip. Yeah, it's a big boy. I've never used a tool like this before, but we'll see. We'll see. I should use different tape. I need multiple layers of this tape. It's funny, the tape I actually used in Quinboxed, it's called OK tape. And it's okay. It's not great. It's certainly not great tape, but it's okay for what I used it for. And that is obfuscating addresses. I use better tape for everything else, but it's like $2 a roll, so, yeah. It's not fun unless you break something. Well, I break a lot in this room. This room has seen a lot of broken stuff, so, yeah. Oh, hey there, Bastian. Every week use them? What do you use every week? Oh, need a vise or gorilla. Oh, okay. Can fit a lot of LED strips in that box. Yeah, I guess so. But we're first doing something non-LED related, and then maybe when there's time and I feel like doing it on stream, because I do want to fix it today, we'll look at the secret and try and repairing it. But it's a tough repair job, so who knows? Broken dreams? What? Oh, you have a battery powered one. Wow, okay. Yeah, well, this one was already kind of breaking the budget. I'd have to check my own description to see how much it is. Let me look it up. This was not a cheap tool. Even though it's from AliExpress. It's in the description if you guys want to look it up yourself. Let me see here. Oh, there we go. I paid 123 euros. So, yeah, but I can imagine. I mean, they had to ship this thing, and it weighs at least like 6 kilos. So, yeah, I mean, do we get secret smoke? I don't know. Maybe. I already broke something yesterday, but it was without smoke. So, yeah, that was sad. I didn't mean to break it, but it broke anyway. So today we're rocking the Coke Vanilla, the lemon stuff. Oh, you're on the frame, and the cherry. I think I'm gonna go for the vanilla. I like the vanilla. Well, I like them all, but you know. Oh, you were talking about everything's broken in your basement. No, this is actually my garage. It's not my basement. I've been thinking about maybe adding a basement to the house, but it's a bit hard to do after the fact, I guess. But, you know. Nice, Jocko. Are your batteries in? Yes. Should I share a picture? Should I share? I spent a few hours last night doing something. I'll share a picture. Hold on. Shh. It's the pre-stream. We can do that, right? Oh wait, it's my stream, so I can do anything I want. Let me look that up. Hold on. Nope, that's not it. Something like this one? Yes, but no. Okay. Shh. Let me see if this works. Yes. And then let's do this. Let's remove this. Okay. Are you guys ready? This is like the pre-stream secret now, not the post-stream secret. So we go here. And then I share, I think this one with that. Boom. No, okay. Let me resize that real quick. There. So for anyone asking, are the batteries in yet? I have this answer. Okay, I think that's long enough. You've seen the batteries. There will be more info soon. Okay. Oh, Johnny's here. Hey there, Johnny. Oh, and of course my LEDs turn pink automatically. What do you say about that? I opened my can, but wait, the batteries were also in the charger video. Yes. Actually, they were in the LED video before that, and nobody noticed. So in that 24-volt addressable cob LED neon strip video, I put 2 Easter eggs. Nobody saw them. What am I to do? What am I to do? Nobody saw them. The batteries were actually there. But yeah, in the charger video, it was connected to one of the batteries. So I mean, yeah. But yesterday I unpacked them all. They all look great. We'll have a video about that soon. Yes, Robert. It's 70 times 280 amp hours, so that's like 900 something watt hours. So roughly 60 kilowatt hours, something like that. What's the other? No, it's both about the battery being in the video and the battery boxes and things like that. Nobody, 0 comments. None of you noticed. What about the fire safety side of the battery? These are lithium or LiFePO 4 cells. So I wouldn't even know how to set them on fire if I wanted to. We're scanning for secrets, not Easter eggs. Oh, okay, touche. What is this new addressable LED strip you were talking about? You mean a 24-volt addressable cob LED strip? I need to check something real quick. Is this working? Yes. Okay, this is working. It just wasn't doing it. Let's go to medium speed. Okay, let's try. I was wondering if my background LEDs were working. Let's try totally loco. Yes. Okay. Seems to be working. Let's go back to medium. Okay. Ah, yeah, there is another one coming soon. I have several variety of those. But since the software support isn't ready for those yet, I haven't shown them yet. And as soon as as the software support is there, I think it's being worked on, I will show those to you guys. And up until that point, not sure how useful it is. I don't like promoting things that aren't there yet, basically. So, what BMS I'm going to use? I have some JK BMSs, Time. Will there be blue LEDs tonight? There could be if I fix one. Maybe after we do all the cable stuff. Can we join a live stream live? I don't know. This is my life, and I am streaming it, and it's live. I don't know. Hello. Hey there, Savag. Like a meet and greet. Oh, sure. I am actually considering one. I mentioned it before. There is going to be a camp zone this year. That's a Dutch LAN party event we used to do for like the past 20 years or so. But then COVID hit. And I'm thinking of maybe organizing a meet and greet and maybe a workshop or something like that over there. Flart, I have met Quinn in real life. I had the whole meet and greet experience. Oh. No way you are at Camp Zone. Are you too, Bastiaan? I would have never imagined. Yeah, but I'm known to be here and there. The battery in the shell behind of you a week ago? I don't know about that. Speaking of the closet though, I like rearranged everything. You can't really see anything, but I did a lot of cleanup work. It's a lot better now. Give them to Snoei. I bet it'll get them to burn. That I have no doubt about. But the idea is to use the batteries. Find the Queen door. Yeah, so far I have tested 13. So I have a little program in my tester which first charges them up, then waits 5 minutes, then drains them to a certain voltage, waits 5 minutes, and then charges them up again. And so far they've all come back as above 280 amp hours. So that's good because they're 280 amp hour cells. I even have one that's 291, but that will come in the battery video. When does the stream start? This is the pre-stream. It starts at 9:15 or 21:15 or yeah. You guys can watch me wrestle with cables, which you've been doing for years now. So show the crimpings. No, we'll wait. This is pre-stream. I need to drink. I need to hydrate. You know, I need all the strength to make that cable in a minute. Oh, I was looking at the AliExpress. Okay, people are coming in slowly. We want to see the tool. You will. Actually, not on the top cam because it's not wide enough. This is going to be fun to watch. Yeah, I am by no means an expert, and there are some friends of mine in the chat who are better experts at these things, so that's going to be fun. Did you even lift those batteries? I did, all of them, multiple times. They're quite heavy, actually. 50k subs is just around the corner. Can we expect a big secret reveal? I share my secrets with you guys all the time. How am I supposed to keep a big secret? Good evening from Manchester, UK. Do you have a fill button? Not handy, no. I should have one here. Like, permanently mounted, like, over here or something. Because I fill regularly over here. But that's the thing. Then I learn. We have a friend called Glenny. He also needs a guy for crimping his cables. Well, I'm not it. I can tell you that. I did not bust the hun. In his garage. You don't want to have a meet and greet in my garage. There's barely any people fitting in there. It's full of batteries. True, if you don't fill, you never learn. Yeah. Can't do everything right on the first try, and sometimes you know, just need to investigate and try, and then you find the right way. Quinder is like the Mythbusters. Don't try this at home. We do this so you don't have to. Kinda. Fried camp? What the hell is fried camp? Are we frying electronics or like fries? You bring Snoei and snacks. That's always good. That's a good combination. For sure. Yes, we are going to be hiding those batteries in a enclosure. It's not a rack enclosure. It's something I custom designed together with some Chinese folk. But we'll look into that later. Or in another video. It's not for now. Shh, shh, shh. Let's ring his bell now. Okay, I'm going to check my cameras to see if you guys are at my door. I don't think so. Of course, I have lots of cameras. You know that, didn't you? Aw, no cars. Not in the street, not in front of the home. Nothing. Aw, too bad. Hey, but if you're here, you could show me how to use the tool properly. That'd be fun. Actually, I hope I have the right tool this time, because last time it wasn't the right tool. I mean, it was the right tool for these. So this one's crimped. This one's crimped well. This is good. But the Andersons, well, I put heat shrink over it to hide it. That wasn't great. But yeah, we'll work on that today. Yeah, I'm totally crimped. No, what? Be careful what you wish for. Yeah, I know. You have an apprentice? What? No, I don't. Where is he? Quinbox batteries. No, I think it'll be a regular video, but we'll see. I still do have some Quinbox to do, though. But, yeah. It would be funny if you could ring the doorbell without being on cameras, because there's at least 3 cameras pointing there. So... What? A tool? Okay. Yes, we're trying to get these type of plugs to work. Where is it? Let's see the one where... Okay, yeah. So these type of plugs, these are Anderson SB or SY in this case. It's Chinese knockoff. 175 amp connectors. And they take 50 millimeter square cables into there, and then they interlock. If you have another one, oh wait, here we go. If you have another one, you can reverse. Basically, well, let's see if we can do that. There we go. You can basically hold them together like that, and they'll, if you have enough power, they'll snap together like that. So that's what we're going to try today again. Because we kind of worked last time. I think technically it would work okay. But in reality, it didn't look great. Oh, it's 15. Get the tool out. Show us the tool. Good evening. How are you all doing? Hey there, MSX Droid. Well, I'm being pressured. So let's get the cable out of the way. I snipped off some cable. I didn't want to work with the whole roll anymore. You guys saw the whole roll last time. It's 20. Oh no, I'm too late. Okay, so let's see if I can get this. Yeah, that's not going to work. Let's see if I can zoom out completely. But then, okay, we'll do it for now. You know, my mounting construction is visible and things like that. So I already secretly kind of opened it. But I generally don't get this packages this big. So let's get this out of here. Yes, it's really big. So it came very well, nicely packed. There is a big box in there. Okay, let's get this over there. Okay. I still can't show you. Sorry. Oh, let's get this done. There we go. Oh, it's quite it's quite heavy and really, really big. Oh, sorry about the noise. Okay, so this is it. And this thing is huge. It's an iwiss, and that's actually a brand, CT80, and it can do 80 to 80 millimeter square cable, in theory. And let me show you on the face cam here. I mean, oh, messing up some wires here. Hold on. Yeah. I mean, this, yeah, it's kind of, hope I'm strong enough, who knows. But this thing is really heavy. I mean, it's like, I'm not sure, I don't think it's no, it's not a solid block. But look at the construction on that. Nope, don't look at the face. Nope. Okay. In theory, oh, who wants to be a my first piercing tool? That's it. So in theory, it has a little knob here, and I think we're supposed to, yeah. And then it has this wheel. Oh, but I need to open it, I think. Okay. This camera's a bit dark, isn't it? Hold on. No, other way. There. And then we can move this wheel, and this says, I don't think you can really see that. I'll try and zoom in. There. So this says 8, 25, 35, 50. And I think we want a 50. So I think we position the wheel like this, so that when it closes, well, the pin gets pushed in. So I guess we should center that kind of like that, right? So let's lock that down. Can be used for bone piercing. I have no doubt. Did you read the manual? Is there a manual? What? There is no manual. This is a product for men. Doesn't need a manual. Okay, so yeah, that's how it's supposed to work. Basically, if you open it up, the pin goes outward, and then you put your pinky in there, and then you crunch it down like that. This is going to be interesting. Right. Okay. Let's focus that. There we go. Just size up with your crimping tool. Yeah. We're using 50mm square cable. So we did these ends last time. I think in the end we're going to snip them off. And for this cable, on one end I want Anderson plugs, so I can use one of these connectors. And on the other end, I think I want lugs, but I don't know what lugs. So I think I'm going to just use this as testing cable and make Anderson plugs on all sides. And I don't know. Let's snip off what we did before. And do I care if they're exactly as long? I guess if I ever use this in reality. My desk isn't made for this type of cable. Damn. Okay. There are just battery tools for this stuff. What? What do you mean, Bastian? What amps are you pulling? Oh, well, these should be okay up to like 100 continuous or 200. I'm just gonna snip this off right here. There, that's one. And then this one should be about the same length. I don't know, just for fun. I'm not going to use this cable in the future, I think. But let's snip it off almost the same. There we go. Okay, so these were our pieces from last time, and they were pretty good. This is another one of those cutting tools. I had two, and they actually cut pretty well, I think. I mean, yeah, looks pretty good. Right, so let's get the baggie, and we need 4, because we're going to do both sides. We're going to make this a proper cable. I guess my 5-year-old daughter shouldn't be playing with these tools. I don't think so, because this will snip off your finger too. I have no doubt. So first thing is, okay, we don't need all of those right here. She would be cutting everything. Don't give your 5-year-old scissors, let alone these things. Hij is toch Hollander? Wat bedoel je nou? Yes, these are the same exact lugs as we were using before. Windows Defender, I don't care that you scanned my PC just now while I was streaming. Thanks, Microsoft. And no, YouTube, we don't need an ad either. So we should size up the wire a little bit. And let me. There. In theory, we need to strip off as much as we, or have as much exposed copper in here, and then, you know, get it over here. But in reality, if it's stripped off slightly too much, we'll use heat shrink over this anyway, so it doesn't matter too much. But basically, let me try and something like that. Let's try and indent that with my fingernail, because I have long nails, as some of you like to point out sometimes, and then curse about it. Okay, so we need to kind of score the cable. So I'm first going to try that with my cutting tool and probably fail horribly, and then we'll go back to the scissors. So it's kind of clamped in there now, and I'm just going to try and turn it to see if we can get to the outer isolation. I think I felt some strands, but I'm hoping I'm not through it yet. Well, it looks fairly decent. Let's see if I can rip this off. Sure, you can fit the whole connector inside of the housing. Okay, so we have this part holding on, which is slightly too strong. So I'll give that a little snip. Okay. Well, that looks pretty good. There's no strands in here. That's always a good sign. And these strands look pretty good. Oh, no. Okay, there might be some cuts here. Can you see that? Box cutter might be more appropriate. Yeah, I should have it. I have a box cutter. I can try that too. Finally catching live. Love the Dick Quad. It just works. Excellent. Okay, so next step should be to get this all in there. Okay, and this is actually stripped pretty good because it's bottoming out. I can't push it in further than that. So there's a little gap here, but that's okay. That's fine. As somebody already said, it's either in the housing or I'll heat shrink it anyway, and then it's fine always. So, need a pipe cutter for that size wire. Yeah. Hey, unexpected maker is here. Nice. We're playing with 50 square meter cable here, or 0 gauge. Okay, so we have the copper inside of the connector now, and I'm going to try and show this on camera. Let's try and open this up. Okay. Okay, so everyone who's here, let's make a poll first. Wait. So when doing a crimp, should you crimp at the end first or at the beginning first? Because we can do 2 crimps, right? We will do 2 crimps. And I'll make a poll out of this. Hold on just a second. It should allow me to do that. Participants poll. No, how do I make a poll? Start poll. Yes. End or begin crimp first. End. Plug side. Begin. Cable entry side. Ask. There we go. Yes. Okay, let's see what happens. This is, of course, the best way to source information on the internet. You ask random people in your stream what to do. I mean, it doesn't get any better than that, does it? In the middle? What? You didn't ask him and had a mill option. Okay. Can I still add options? I don't think so. No, I can't. Gigavolts, gigaamps, yes. No, this is for a home battery project. I'm starting Quinergy, and I'll be building about 60 kilowatt hours of battery banks using LiFePO cells. So we need some big boy cables for that. Just hot glue it. Yes, that is always the solution. Send the tool back, get a wire one. I'm sure they'd make them, but they'd probably be even more expensive. I would solder them. Yeah, but I don't like solder creeping into the wire and then, causing issues there. In theory, a crimped connection is better than a soldered connection. So, okay, we're going to give it until 21:30 on my clock. No, not planning on burning the house down. This is using LiFePO 4 cells, so that should be relatively safe. Just use plumber soldering? No, do both crimp, then solder. Oh my god. That's probably better than soldering and then crimping, though, but, Use a large hydraulic tool. We tried that in the last stream, it didn't work. Or it worked, but it wasn't pretty. Lightning hit the tower at 2300. Be quick. Okay, so, it's still 21:29. I have to give the people a chance to vote. Okay, I'm closing the vote. It's 59% for cable entry side. And it's 57% now and 43% for end plug side. Right, so let's end the poll. Okay, I guess I can copy paste this real quick. Oh, okay, that doesn't look great. So the begin cable entry side wins, and we had 53 votes. MIG weld, just weld it, yes, but I don't have a welder, so 1% didn't vote. It's almost like pushing the like button. Seems they are able to find the vote button better than the like button, though. Hint, hint, hint. Okay, so we're doing the entry side first. So I'm going to be placing this in here. And I guess I'm going to tighten it just a little bit first. I'll try and show you in a minute. Okay, it's holding it now. So it's in right past the bell mouth. And do we have an opinion if the crimp should be on the side or on the top or something like that? Doesn't matter. Because now they're going to be on the side, right? Because this is how the connector will be. You need 2 more hands for this. No, I'm okay. Where did you get these cables? From a shop. I don't think it's matter. On the top, another pole. No, we're not doing another pole. We're gonna do 4 of these so we can actually try it out. Oh, you broke the screen, Have a 6 star. Thanks a lot. On the top and bottom. Oh. You would turn it 90 degrees to crimp. Okay. Okay, so let's turn this. There we go. So now it's like that. And oh wait, I need to make sure it's so it's lined up like that. Okay, let's hold it in there. Now I'm pushing on the cable slightly to make sure it's in there fully, and we're going. That went very easy. Oh, okay, it might have come out slightly. Not sure. Let's see here. Yeah, okay. Well, it indented correctly, I think. But it's certainly not big enough. Okay, let's see if I can get the cables back in there. Or the strands. I think we might need to go to a tighter setting. Okay. Oh, no, missed some strands. Damn it. I'm having issues getting all the strands in there now. 1 second, please. Wrong plug or wrong wire. It went in much... Yeah, well, we can try a different size. Let me get this in here again. Okay. I think I have all the strands. Okay. So, that didn't work. It is on 50. Oh, no. It might not be on 50. Wait, what? Hold on. Yeah, it was on 50. That didn't work. Let's go to 38. I don't know. Shrink tube it. No. Let me make sure this lines up. No. I'm not going to get a fresh one. We're just going to crimp this one again. No harm in that. That's why we're testing, right? So it's on... Oh, let's see if I can get this in here. I can. Okay, and now I need to hold it. Okay. So it's on 38 now instead of 50. So let's see what happens now. It's actually very, very light. Oh, wait. I need to open it more to get it out. Okay. Well, that is certainly some indent there. Right? Let me make sure that's in focus. There. That is quite a hefty indent. I mean, if you... Yeah? And this... I can still pull it off if I want to. So, is that still not tight enough? Yeah, exactly. The manual said do a YouTube pull. So, I can still pull this off if I want to. That's nowhere near tight enough still. What do I need to do? I guess we're going one size smaller. No, I mean, this is a 8 to 80 millimeter crimper. I mean, what else do we want? Crimp it on all 4 sides? I don't think that's going to work. We are moving to 25. Let's make sure that's centered. Think so. 50, but both sides? No, the idea is that it crimps in there, so... Alright, so let's get it back in there. We're now going to try 25. Okay. I'll probably have to put a little bit more pressure on it now. Oh my god, okay. I think this is definitely... This will have definitely crimped it. I mean, there's now even an indent on this side. And on this side. But, yeah, I can actually see the strands here now, so... I guess that's not good either. Damn it. I really thought this tool would do it. Okay, well, it's on there. That's for sure. So let's do a second crimp, I guess, over here. But this is too much, because it actually broke open. Now, in the end, as long as the connection's good, I guess that doesn't matter, but... What tool are you supposed to use with these things? What is going on? So, let's do the second one. And we're doing it over here, I guess. Okay. And now it looks like this. I mean, that's on there. If you can see how much this is crimped in, that is definitely... No, I don't believe we figured that out, Philip. I think we figured out that the tool was wrong for, you know, these crimps. I'll, you know, when we continue this saga, I'll order some official lugs from Mauser or something like that. But those are really expensive. And this kind of works. I mean, this isn't going nowhere. Right? I have no doubt that this is a solid connection. It's not pretty, but then again, when I look at Anderson plugs on the internet, they're never pretty. So... With a LiFePo 4 battery connected to a Dig Quad, can I wire a DC rocker switch before the board to switch it on and off? I wouldn't use a DC rocker switch if you're running like 20 amps through there. That thing's gonna melt. A hexagonal crimper, yeah, well, but that's the one we used before, and that didn't work either. Yeah, I don't know, man. In theory, this should be the right size. That's what we determined last time. So the 1/0 is for like 53mm cable, and I have 50mm square cable. So, hey, later, Bastiaan. So yeah, I'm not sure what's going on here. Why it's still not good. Yeah, this'll work. I have no doubt about that. I mean, we can just, let's see here, like that. There we go. That's in there. That cable's going nowhere. And you probably indeed don't even need heat shrink because the cable is in there pretty far. So there's no way you can reach that. So yeah, let me try and get that out again. Yeah. There we go. So it's not pretty, but I think it's a better result than we had last time with the wings. Don't know. There is no manual for something like this that way. Sure, join the Discord there, John. We can usually figure it out. Yeah, if it's not too big, the exposed part with these connectors, I think that's fine. You don't really need the heat shrink, but yeah. Okay, well, let's do the red side too. And see if we can improve on the results. I don't know. Anybody have any tips how we could improve this? Other than buying other lugs right now? Later, Bastiaan. You don't love the exposed copper? Yeah, but this type of crimp is meant to be that way. Because then you either heat shrink it, or you put it in the plug, and then it's shielded anyway. So, that's pretty normal. Use 35 size? Sure, we can try that. see if I can get this one off. Oh, okay, that's pretty good. So we have a new... Oh, a strand fell out. It's okay. One moment. Okay, so we have the cable again. It's not a perfect cut, but it will have to do. So use 35 instead of 25. Okay. Let's take the plug out again. No, that's not an error. It's hard to get the length exactly perfect, and I'd rather have a little bit exposed so that I know everything is inside of the plug than maybe not have it all the way inside of the plug because the heat shrink is hitting the outside. Okay, use 35 and crimp from both sides in the same spot. Sure, we can try that. So we're now at 35 again. Don't think you can see that, but that's okay. Let me get this inner plug. Nope. Missed a few strands. Oh, missed one strand. Really? Okay. That's all of them in there. It's at 35 already. So let's open that up. Yeah, that could be, Johnny, that it's the wrong type of cable for this plug. Sadly, I already invested a few €100 into that. Okay, let's do it sideways this time. Shouldn't matter too much. Let's hold it down, push the wire in. Okay, here we go with 35. Okay, that looks like the way it looks. Okay, now let's turn it around. If the cable will let me. And do it exactly the same on the other side. Oh, man. Okay. Okay. So now we have a crimp indent on this side and on that side. Let's do the front of the plug. That's, the first one's easy, but the second one is a lot harder because it's already compressed. Okay. Okay. There we go. Oh. It broke through the shell again because I was probably too close to the plug side. It didn't... Oh, it also kind of did on the other side. But these... yeah, these are on there. I'm just moving the insulation. Sure, you can do it with solder too. Maybe these are meant to be soldered. I don't know. For the people who like insulation up to the plug, there I move the insulation. I can do that on the other one too if you want. There. I corrected your issue with the insulation there. So how do we feel about this plug? With the 35 on either side. You can see they go in quite far on this side. And they don't go in as far on the other side because, well, the cable's in between there. So you feel this looks better and crimped from the sides. Should still fit. Let's try it. Plus, yeah. Yeah, that fits just fine. How thick is the wall of that plug? What do you mean? This one? Fair. It's not very thick. Not like the lugs. Yeah, you're not going to pull this one out. No. The hex crimper doesn't work for Anderson plugs. We tried that all last stream. That didn't work out. So yeah, now we can make this connector, I guess, like that. And well, the end result would look something like this. And even if there would be some exposed copper, it's all the way down there. So the plug goes about up until there. So over here. So even if you'd have a little gap of exposed copper, there's basically no way that can reach the outside. But I can just move the sheath and then it's no problem anyway. And yeah, then you get this connector here. And you can get another one, which you terminate the exact same way. And because it's in reverse, polarities line up. And there we go. Yeah, that's not bad, Johnny. Last time it took a lot longer. Hey there, Hope. Okay, let's do the other side of the plug. I'm gonna release it from here so I can twist the cable still. The screw holes are actually for attaching it to something if you want to. Because the bottom side of the plug, so this side, can be flat, and then you can still insert one. So even if this would be lying flat and screwed down to like a metal plate, hint hint, you can still get another plug, and it'll go on like that. And in theory, that should still work while it's mounted down. Ooh. Arc shielded? You mean the plugs? You mean? I think they're insulating just fine, and I could add heat shrink. I might anyway. For instance, if I didn't have colored cable, I probably would. But I decided to order the cable in the colors that I wanted them to, red and black, because it wasn't much more expensive. So let's get these out of here. Nope. Come on. Release, please. Release blocks. Nope. I'll check the tools channel after the stream, Philip. Oh, they're made to keep the arc inside. Yeah, but you shouldn't plug them with like 175 amps on them anyway. They're not rated for that. I guess it depends on the voltage, but yeah. Okay. Okay, so let's do... Okay, so now we have a gap here again, but that's because I pulled on the insulation. Because if I do this... There. Now the insulation... meets up with the housing of the plug again. Yes, there will be a DC side. When? I don't know. I don't know yet. Soon, I hope. It's one of the first ones I'm going to be working on. So. Okay. Let's do that again. So we measure the insulation depth and we say, okay, we want to cut it about here. And then let's try and do that without cutting the copper inside. sure that's long enough. That is not long enough. Okay. Let me get it a bit longer. So I'm just trying to score the outside mantle here. Should be okay. Nope. Okay, I need to cut it a little bit to make sure I can get it off. A few of them. I think about well, at least 4, but I'll probably use them for more stuff. Didn't score this one very well. Okay. Okay, there we go. Huh. I needed a pair. Yeah, but I mean, as in cables, I mean 2 inside of a plug, right? So I need to do 4 crimps in total for 1 cable. Yeah, that sounds about right there, Felix. I thought that would be plenty for like a battery. Okay, let's try and get this in here. Okay, that looks pretty good. Yeah, I'm not gonna try and do 100 amps hot plugging. The system I'm designing should have breakers and things like that at all the appropriate places. 280 amp ones? No. These are SB 175 like, so yeah. But they can handle a decent amount. So the last one I did on the side, I guess I'll do this one on the top and the bottom. Let me grab that. Okay. Hold the cable in and there. Should we do 2 sides at the same time? Because that would make it easier. So now I'm just going to do this one here. I don't want to do it too far to the edge because that's going to break the plug again. So like that. Okay. Well, it's certainly indenting, unlike the other tool we had before. Okay. Let's do the other side. Hold on. Let me check if I'm at the other side. Yes. This is already a lot harder. No, it needs to be opposite of the other side, because then you're really compressing the cables inside, because that's the idea. And that's what I'm feeling here with the resistance. Okay. That actually looks pretty good to me, if I'm honest. So this is fine. Oh, sorry. This is fine. You know, this is indented nicely. And then the other side is okay. It cracked the shell a little bit over here. Not that much, but this is certainly on there. Oh no, one thing I didn't pay attention to is how these are lined up. I think I also like it better with top and bottom than the sides. From the sides it just looks weird now. Yeah, top and bottom, I think is best. And then 2 crimps. And this is on there. This is a good connection. I'm not too worried about that. In the end, we'll see. I mean, we're gonna do tests with like thermal camera and stuff like that to see how warm the connections get. So, in the end, we will have our answer if it's correct or not, or if it's good enough. But I can't do that right now because I don't have anything, you know, to generate that kind of load. I will at some point soon, but yeah. I think a vise would work. Yeah, I have another type of crimper ordered, but it's basically this type of crimper, but then with where you hammer it. And I also ordered this clamp because it looked really heavy duty, and it is. Okay, let's give it about here. Ah, no, Stefan. Between the cables themselves, or between the cells themselves, so like I'm building a 16S battery, I have bus bars. So those just screw in basically. And then inside of the battery enclosure, there will also be some cables and things like that. But that's going to be using lugs instead of these Anderson connectors. These Anderson connectors are only, well, basically for the outside. Connecting it to the rest of the battery system. Okay, let's see if I scored that somewhat decently. There, okay. Try and break it a little bit more. See, I always get this. Oh, dropping frames? Uh-oh. Yep, we dropped 353 frames. Don't know why. Seems to be fine again, so... 0.1%. Probably a provider hiccup somehow. Don't think that's on my side this time. Damn it. Yeah, I looked at the SB350s, Felix, but I felt like that was going to be overkill. Once I have all the battery enclosures up, an average current should be like 50 to 60 amps. I think that's fine. Yeah, I have a knife actually. But I'm always worried about cutting myself and the strands. But I guess this should work. Okay, let's try it now. Yeah, there we go. Okay. Yeah, knife is good for that. Better than the scissors. Okay. It's a bit too long, and this isn't even anymore because we've been pulling on this cable. But it goes in far enough that I don't think that's a problem. There. I mashed it in a little bit. Okay, let's open this up again. So we said we wanted to do top and bottom. Ooh. Okay, I need to clamp the plug down first. There. And then put the cable in. And then there. And let's do it a second time, not too far to the edge. There, like that. And then let's turn it around immediately. Do it first over here. Oh yeah, okay. Hold on. And then a second one over here. Oh, slightly more forward. Hold on. There we go. Oh yeah. Okay. Well, at least this confirms that the cable's getting compressed inside of there. Okay. There. Okay. So, yeah, well, it looks pretty decent again. There's a gap here from the housing cracking, but there's enough copper in there. I think that would be good. Doing it standing. No, I'm probably putting this tool in a vise would make it easiest, but yeah. Yeah, exactly. We can, build muscles like this. So, now, we have two cables that are crimped. Fairly okay. Fairly okay. Actually, I wanted to do soldering after this. I'm not sure I still can with all the power. Cracked is a no-go. Why is that, Barry? Because I think it's going to be hard not cracking these connectors. So, these have a plus and a minus symbol. So, oh wait, this is a used one. Plus and minus symbol. Plus and minus. So let's do plus. Oh, this is also full. Okay, let's do plus. No, I don't have anything yet to power test these with. Oh, wrong way around. Okay. There we go. And minus. There we go. Let's get an empty one. There we go. And we have minus and plus. There. Well, the rest of the plug is connected. It's not like it's a big gap there or something like that. So I'm not sure I agree with that. It's still not ideal. Turn up the heat, yeah. It's still not ideal, but I agree with that. But it's the best I can do right now. So now we have this cable. It's quite heavy, if I'm honest. And it's connected in these plugs. And even if there's a little bit of spillage there at the connector side, that's not a problem. You can still heat shrink it if you want. And in theory, we can now connect it together like so. Stefan, in theory, I guess you could, but that's not going to do anything. I don't have enough loads right now to make this do anything. Infinite power. Yeah, Skodo, I don't have the tools to cut inside, but judging from the resistance, those strands are getting well compressed there. Braided coverings? No. Use this for power injection. Yes. You need 0 gauge or 50mm square for power injection. It's quite heavy, actually. I think it can stand by itself. Yep. Oh. Yeah. It's okay. I like it. It's a little bit twisted. Dremel it. Yeah, I don't want to create that kind of mess right now. Sorry. There's other stuff I need to do. Yep. For the people wondering what kind of cable it was, it says it right here. DGR 50mm squared IEC 2456 2022 part number 530574. Okay. So this is 50mm square cable. I don't have a doubt about that, but I don't know what's going on with these plugs. It did also fit the lugs correctly. So if you take a look at this lug was crimped with the same cable using an SC50-6 connector. So that's a 50mm square connector. And this crimped down perfectly with a hexagonal hydraulic crimper. So, yeah, it's the right cable. The cable is 50mm square. The plugs are just weird. I don't know what's going on with the plugs. But yeah. And it looks like good copper. That shouldn't be a problem. But in the end, I will be checking all the connections regularly with a heat gun or a thermal imaging camera to see about resistance and how hot they get and stuff like that. So yeah, that's when we'll know. That's when we'll know. I mean, I think these will be okay, even with the cracked shell. I mean, it's not pretty, but I think it's very functional. It's better than we had with the hexagonal crimper. That I'll say. I think. I don't know. Anyway. Don't forget to measure the resistance of each cable. Yeah, I don't know if I have something that can measure that low of a resistance, basically. 12 to 1/0 gauge cable, yeah. And I'm using 50mm square, so... Yeah, but Anderson plugs should also be crimpable. So where's that going wrong? I don't believe these plugs are only meant for soldering. Exactly, yeah, Felix. Insulation resistance meter on low ohms. Okay, but I only have a multimeter. I have a very nice multimeter, but I only have a multimeter. It does say low sense and high sense on there, if that means anything. Yeah, well, we've been having these discussions for a while now, so this was just another try and see. I think this is better than we had before. Still doesn't look ideal. I will order some official Anderson plugs locally and see if those do better. Not sure I'll make another live stream or video about it. I'll probably mention in a video at some point. But, yeah, that is what it is. I think these are usable, but I agree that it's not perfect yet. High impedance meter? Okay. Yeah, I don't know. I have a... Okay, you can look it up. I have a Siglent SDM 3045X. So SDM 3045X. Let me know if that could measure that type of resistance. I don't think so. So, let's get this off the desk. Oh my god. Because there is something I need to do today. And I'm thinking, as a bonus, why not take you guys along? And that is also going to be the secret of today. Are you guys ready? Oh, it's not in focus. There. This is a prototype for a Quinled AN Mini. Oh, Philip is there with a donation. With that out of the way, time for some secret things before I go. Yeah. I believe Anderson plugs are also crimpable and solderable. So, yeah. And I like crimp connections better than soldered. Depends on the purpose, but yeah. So, this is the Quinled AN Mini prototype. It's already the second prototype, because on the first prototype I screwed up some things, and we're not going to talk about that. It's a analog dimmer board using an ESP32C3. So, it has a USB connection. It has 3 button inputs, and then ground and 3.3 volt. Power input. It has a fully custom buck regulator circuit. Then it has built-in fuse protection, but then, since this is meant to be a pre-assembled product with a nice case and everything, those aren't replaceable fuses, but they are PTCs, so they'll close automatically if there's a short condition and then open automatically again, so auto reset. There are 5 MOSFETs on there. This one has different types to test it. There is a MOSFET driver circuit on there for 2 of the channels, because the idea is we have 5 channels, so we can do RGB, and then we can do cold white and warm white, but cold white and warm white often use more power, so those are driven by a MOSFET driver circuit that does 5.18 volts or something, and the others are driven with 3.3 volts directly. And there's, you know, capacitors and all kinds of crap on there. What? Oh, yeah, the hole? Yeah. So this was a little experimenting. There is a temperature sensor on there. The final product probably won't have that temperature sensor. Over there, that guy. Let me try and show you there. The final product probably won't have that temperature sensor because it's kind of useless, especially inside of a case. But there is a connector over here, which is called a Stemma QT connector. And you can take, you know, these prefab little boards. This one, for instance, has a temperature sensor on there. And you can just plug it into the board. And now you have an external temperature sensor like that. And you can get longer cables and things like that. So yeah, this is a 5-channel analog pre-assembled board I'm working on, and it was working great until I shorted it with the power supply last night, and I think that blew up the ESP. So we can take a quick look at that. I need my thermal camera for that. One moment. We're going to use my Doji 98S. Okay, I need to zoom out a little bit. There. Let's focus on the thermal camera real quick. So I have a FLIR and I have this Doji, and if I want to do a quick measurement, this Doji is often easiest. I'm going to connect the USB-C, but the USB plug is turned off. I have a little power meter here. I don't think I can... No, I can't show that on screen. But I'm going to be watching the power meter. What you'll see is currently... the board, trying to get that on screen. The board is basically cool to the... Oh, wait. I need to do something real quick. Something like that. Trying to get the camera on screen. There. And now focus. Oh. There we go. Okay. So I'm turning USB on. Okay, it's immediately drawing 3.3 watts, which it shouldn't do. And as you can see over here, it's quickly starting to heat up. That is a PTC fuse on the USB plug and a diode. And for some reason, the ESP module itself is heating up, but it's not turning on. I mean, the LED is on, but the board itself isn't turning on anymore, and it doesn't connect to the network. And if I keep this going, we can already see 66 degrees over here, and in the end, the ESP will just be about 100 degrees, and it won't boot, and something is broken. Now, looking closer, it really looks to be the ESP itself. It's already 50 degrees. And nothing else. Now, the dark spot here is because there's a metal can here, so it doesn't understand that, can't read that. But it is actually heating up if I touch it too. Now, USB is only supplying limited amount of power because there's a PTC in there. Yeah, so this isn't working anymore. This was working fine. This isn't working anymore. So what I want to do, let's disconnect that real quick. Auto desoldering circuit. I wish. It doesn't get hot enough for that. But what I want to do is, yeah, that's hot. is replace that ESP32C3 module. And that is actually quite a chore because it only has pads on the bottom, right? So I need to heat up the whole board and hit it with hot air. It's working fine as a space heater now, yeah. I need to heat up the whole board and hit it with hot air while trying to remove just this thing and replacing it. That is a difficult task, even if I do that outside of camera. But we're going to try it. We're going to try it anyway. And the PTCs are kind of in the way. In the end, these can be folded kind of flat to go into the housing. But of course, we don't want that right now because, well, we need to reach the ESP32. So I'm going to bend these back a little bit. Let's try and focus once more. There. Yes, I solder these prototypes myself. Yes. So, yeah, no, I hope it's not time for smoke. But we are going to work on this. So I'm going to put my glasses on. Yeah, but I do all soldering of prototypes myself, because then I can build as many as I need. And why is it still not in focus? There. And manipulate and test and destroy and rebuild and replace components when I intentionally short them and things like that, you know, to figure out how to kill them and then how to improve the circuit so that hopefully it doesn't work anymore, or it keeps working basically. Right, so let me get my hot plate. Because the best way I have found so far is we're going to put this on my little hot plate thingy here, and we're going to boil it. I'm going to see. I need to get this fairly close to me because I need to work on it. So let's get that turned on. If this turns on, that's no problem. Okay. Yes. Okay. Yeah. You know, in the end, the prototype has to reach the production version type thing. Where are my tweezers? Over here. So yeah, this is all 0402 components. They're too small to see. There. Let me try and show you this way. So these, this little thing, for instance, this is an 0402 component. This is everything is 0402, or well, bigger if it needs to be bigger. But then this is my pinky. So yeah, these are small components. So we're going to try and get this one off and then get a new one on there without knocking any of the other components. This is designed for ESP Home, but it'll also be perfectly compatible with WLED. It's kind of designed for both, really. Okay, so I have my tweezers ready, because that's what I need. And we need flux. We need copious amounts of flux. We need all the flux in the world. And we need some solder paste. So I'm going to prepare these. I'm going to get some tissue because that always makes a mess, and I don't want to don't want to dirty my desk. So this is something I wanted to do, or I needed to do today anyway, and this time I'm taking you guys along as a secret, basically. So yeah, don't go copying my board now. It's happened before. Don't do that. Design your own schematics and boards and build those. Okay, so I'm preparing a syringe with low melt solder. Time for a poll. Will he succeed or not? How many tries do I get? Mark, in theory they could, but in theory they could also help work against me, because the Kapton tape or the tape or whatever could pull on the components when they're loose, and in theory, if I don't nudge them, they're going to be fine, and if I do nudge them, I can nudge them back, basically. So I'm going to try without tape first. Third time's the charm. Well, I've done this before. It still sucks. Okay, let me show you what I prepared here. So I have a syringe with... It's not turned on yet, right? No. I have a syringe with some quick chip flux. And I have a syringe with some quick chip... okay, it's the wrong way around. Solder paste. It's pretty old, but it's still usable. This is low temperature solder paste. There's also low temperature solder paste on there, because I always use low temperature solder paste when building prototypes, so that when I need to fix something, then I can easier get it off than if it was high temperature or ROHS, whatever. The connectors and stuff are ROHS soldered, but yeah. Let me get a ESP32. Hold on. I should still have enough, I think. Good. Otherwise, they're one of the reasons I need to do a Quinboxed. Because there is additional ESP32 C3s in the Quinboxed mail, and I don't know which package it is. So we have some spare modules here. Oh, we only have one. I don't know if I have more. I have more somewhere, but I don't know if I can reach those easily. Right. Okay, so I have my spare chip here, right, and it only has pads on the bottom like that, okay, and those are very small pads. So what we're going to do, we're going to turn the heat plate on. I can do that while talking. I'm going to start the suction. Nope, I need to turn that on. Okay, suction started. We're going to heat this board up to, well, it's set to 195 degrees. But the problem is, I've already soldered the backside, so it's not going to lay flat on the hot plate anymore, right? So we're going to heat this up to 195 degrees. There is 138 degrees solder in there, but even 195 degrees, we can keep it at that for like a minute or so. That's okay. Right? And I'm hoping that'll be enough to dislodge or get the ESP module to come loose, and then I can slide it forward. Then we're going to tin the pads a little bit with some extra solder paste and maybe some extra flux, and then we're going to put the new module on there and then hope for the best. An alu strip. Oh, that's actually a good idea there, Johnny. But there's solder joints in the middle too, so that's not going to work in this case, I think. Did you recheck the voltages before putting your last C3 in? Yeah, no, but that would have actually been smart. But I'm pretty sure it's the C3 itself that's been blown up. Because I have multiple power inputs, and the DC converter's fine. I did measure that one. And then there's just an LDO after that. But that also seems fine, so... Now, in the end, the heat will permeate the board. It'll just take a little while. The plate is now at 107. Now, do you guys like me doing this kind of stuff on camera? I usually do it by myself, but, you know, this is just prototyping. I blew it up. Have to fix it. Oh, another thing we're going to fix is this one. This one over here, the D6. We're going to turn that around because it's the wrong way around. But that's just an LED. It didn't impair functionality in that sense. Yeah, I'm heating it higher than 100 because it's 138 degree paste because it's not lying flat. So I want more heat to basically travel into the board. We love to learn from other people's mistakes. Yeah. And it shouldn't not 195, but not directly on the components. The rest of the components and things like that should be fine for a little bit. It's not a pink LED, sorry. So, just to help the process, I am going to be adding some okay, sorry, I need to see what I'm doing here. I am going to add some flux here to the sides. There. So that it can actually seep beneath the ESP32 once it's starting to desolder, and that'll help spread the heat and also solder it later on. I like this more than lug pressing, okay. Yeah, normally I try to, you know, do things for camera, but this is something I need to fix, so I will be in front of the work and stuff like that at some point. Because I just need to make sure it goes well instead of, you know. Now, in theory, I think my tweezers will fit the shield. Yeah, okay, so my tweezers fit the shield, that's good. No, because the components touch, there's nothing on the back, and all the legs are soldered with leadless solder that needs like 320 or 350 degrees or something like that. So even though there's 195 because the heat plate's now done on the legs, it shouldn't desolder any of the legs or connectors. Thanks there, Record Vids. Cool, thanks Mr. Blue. Okay, there's a little bit of smoke. Let's see if we can nudge it. No. Okay. So let's start hitting it with hot air. And I need to set my temperature right. I'm going to set my temperature to about... No, let's set it to 210. Alright. Okay. So I'm also going to hit it with hot air. To just heat it up and, you know, try and get it loose from the board. Because remember, there's also pads, big pads connected to the ground plane on the bottom of it. So the board will need to heat up as a whole to even get it to nudge. And I'm just going to slide it off, because then I hopefully don't touch other components. Or I can try and pick it up, but... Nope, still firm. Yeah, those buttons might melt, but, you know... Okay, let's see. Nope. So there's 195C on the back of it, but not directly touching. And there's 210 on the top. But it's 138C solder paste. That's why I solder my prototypes with that, because then I have a chance of getting it loose. Oh, I got it. I got it. Oh. Okay. I didn't knock any components. That's good. And all the pads, except in this corner here, look tinned. That's good too. But I am going to turn off my hot air right now. And as I said, all the pads look tin, except those in the corner. So what I'm going to do is I'm going to dab a tiny amount of paste there, like that. And then I'm going to take my soldering iron. Oh. Wait for that to heat up. And my soldering iron has a giant tip on there. Doesn't matter. Okay, let's wait for that tip to heat up a little bit. And there is leadless on there. I don't want that on the board. Oh, that's right. Thanks, OC. Okay, the tip is clean. And now I'm just going to hit this with the soldering iron. As you can see, it'll turn into proper solder. See? That turned into solder. But I'm just going to hit all the pads right now. Yeah, this angle really isn't great. Okay, just hit those. There. I need to move one of the capacitors there. Yeah, normally I... Yeah, I need to check with a magnifier if that's good. Almost. Come on. Does not want to stay in place. There. Okay, let's leave it like that. I can't move D6, so D6 needs some hot air. Let's hit it with hot air for a little bit. What? D7? Where is D7? Oh, D7 is fine. That worked. Okay, I flipped D6. That's good. I want a little bit more paste on the pads. So what I'm going to do first is I'm going to paste on here in the middle. So I know I have a lot there. I'm going to hit that with hot air for a little bit. So that it turns into solder. Right? Okay, that turned into solder now. Okay, now I turn off the hot air. Okay. And I basically brush the solder onto my soldering iron like that. And I make a little bowl out of it. And I run that bowl over the pads that I think need soldering. Or need extra solder. Now it might not look pretty, but that's okay. What is touching what? Oh no! This stupid capacitor got extra solder. Let's see if I can still manipulate that. Nope. Okay, I need to do a little trick here. Oh, that's right. C3 slipped away. Thanks. Nope. Nope, don't do that. See, that's the problem with these things. Once you go in and you touch one thing, the rest goes to shit. Okay, hold on. We need more flux. It's gonna look horrible. It's gonna work. Okay, let's get hot air involved. Because now it looks like a mess, right? You go over here. No, don't do that. Let's put you down there. You go there. And you go there. I think. Let's see if that fixed it. Yeah, the resistor is upside down. That's fine. I don't know if you can see better like that, but those are all in their place again. Nothing is touching. That's good. Okay. No, I don't need a smaller tape. That's okay. No, yeah, maybe. Maybe the board will melt. Okay, so we're getting the new ESP32. And to start, I'm going to hit it with hot air. And it's really difficult because I kind of need two hands to navigate it. But I don't need, I don't have enough hands. So I'm going to heat up the pads. I mean, I knew this was going to be a mess, so, And then I'm going to douse it in flux. Okay, so now it's fluxed up. Make sure to get the right module, yes. And now I'm just going to... Oh no. Yeah, I was afraid that was going to happen. Okay, there. And now we get to nudge it. Okay. I need to press down on at least once. Okay, I need to make sure this is plenty heated. So the flux helps get it in place and keep it in place, and it also actively helps with the solder biting into the metal basically, and also not touching to each other. So these little components over here, yeah, that would have been impossible without the flux there. I don't see it floating yet. Let me try and give it a little nudge. Yeah, see, that's not good enough. Oh, there, you saw it move? That means we're almost there. I'm going to add some more flux there. Oh. Okay, it's starting to move on its own. That's good. Now we don't need to win any prizes, it just needs to work. think that's going to be it. Okay, let me turn the hot plate off. So the components still look good, I think. Yeah, components are all on their pads and connected. That's okay. The ESP seems to be in place, I think. Now what I'm going to do is I'm going to hit it with the fan to cool down the surface a little bit, and then slide it onto my cork to cool down further. But if I slide it now, if you even knock it slightly, the components could come loose. So I always try to cool down the surface pretty quickly. Okay. Now I'm going to use the tweezer to slide it onto a different cork here. Okay, that's good enough. Yep. Everything stayed in place. That's good. I'm trying to see if the soldering worked, but I think I see pads. Shouldn't be seeing pads. We can try it, but I don't think the ESP is on there correctly yet. But we'll try it. We'll try it. So let's get this out of the way. Let's move this here. So what I feel like is that I can still see, I can't really show you, I can still see the outline of some pads on the bottom there. And that shouldn't be the case. That means the ESP isn't aligned correctly. But let's get it cooled down. Oh, reflow curve. There is no reflow curve here. This is just brute heating and, you know, trying getting it off. Okay, well, we can use the thermal camera again to see how warm it still is. Oh. It's starting to cool down. Yeah, the brute force curve, that's more like it. Okay, let's see. Need a bit more heat here. Or a bit more air here. Yeah, I think the ESP is a bit too high up, but we're gonna try it with the USB, see how that goes, and then, well, we'll see. Right? Oh, I do need the thermal camera to see if it gets hot again. Yes, I always control the humidity of my my mouth. Okay. So it's cooled down somewhat. Oh, this is a Doji S98 Pro. I think it's in the video description. It's an okay thermal camera. It's not the greatest. FLIR is better, but FLIRs are also very expensive, and this is a phone too, and you know. No, we're not going to pull it. Because I think it's actually up too high. But we'll see. So let's plug this in and see what happens. Nothing. Okay, so it's getting power because the power LED is on. It's correct that the second LED isn't on. That is correct. But it's drawing 0.003 watts. Yeah, that's not good. It's not getting warm. So that's good. But I don't think the ESP is actually getting power. I can try and push on it. No, that doesn't do anything. Okay. Back to the heat plate it is. So this should still be fairly warm. Yeah, 123. That's good. Let's get the suction going. And let's get the hot. Okay, let's put more flux on. Flux, I tell you, flux is the key to everything. Okay. So I'm going to line the edges with flux again. There we go. And let's hit it with hot air. And in theory, it should start to dance at some point. And that means it's hot enough. I'm going to turn up the hot air to 280. There. Need a bit more heat. And in theory, the whole module should auto-center and correct itself. But it'll take a little bit. A reflux oven. So a normal ESP32 has exposed pads on the sides. That makes lining it up a lot easier. Well, this thing, as you can see, doesn't. So yeah, makes it a bit harder. Okay, we got some smoke from the flux. That's good. Let's try and hit it from this side a little bit. Yeah, it's those big ground pads on the bottom that makes this very hard. Okay, let's see if I can nudge it. Okay, I can nudge it. But I really would like it to dance on its own. I know that sounds weird, but... Okay, let me look at the magnifying glass. Yeah, that's probably better. We are now at 0.25% success. Oh, 2.5 chance, I guess. Okay, let's cool that down a little bit again. Is it on there straight? I think so. And these kind of repairs always suck. Because there's a good chance we burned up this ESP already. Okay. Components look okay. Bit burnt. But, you know. So now we at least don't see any pads on the bottom anymore. Yeah, I don't know about this alignment. We'll see. It's so hard to judge because you can't really see anything. Yeah, generally you connect those to ground to sink the heat away. I did add solder to the middle, but then I brushed it off and used the solder ball to tin the pads on the sides, if you remember. I don't have a way to do that. My setup doesn't allow for that. Record vids. No, we'll just get a new module there. Siegfried Hermoto. I should have more, I think. I have done this before, you know. It might not be pretty, it just needs to work. We'll make it pretty in production. Okay, board's cooled down enough, I'd say. I just want to know if it works. Okay, let's turn this off. Oh wait, I need the thermal camera. I need to see how much power it draws. No, hold on. I was booting the thermal camera. So let's see here. Nope. 0.003 watts. That's basically the LED. Huh. Interesting. So, okay, let's measure some stuff then. And if it all measures okay, we'll replace it again. We'll use a new module. Oh, okay. Yeah. One moment, please. What's that stupid app called? There we go. Huh. Oh, there it is. Okay. So now you can also see the voltages. Let's see. Yeah, that's good. Okay. Let's first see if I'm getting 5 volts in through the PTC. Yes. Okay. And then let's see if it arrives here at the LDO. Yes. And then let's see if it makes 3.3 volts. Yes. Okay. Let's see if we have 3.3 volts over here. Yes. Okay. So yeah, you can't check an enable pin. You can't really reach that. But sure. Which one is the enable pin again? That's a good question. Let's check this resistor. That has 3.3 volt there. Oh, okay, I touched it. That's bad. Okay, and it has 3.3 volt there. And in theory, but I can't hold my probes like that. I can interrupt that. Let me try and probe that out. Hold on just a second. Oh, damn it. No. Okay, this is the enable pin, and if I do this, yeah, if I push the reset button, it goes to basically 0, and if I release the reset button, it goes to 3.3 volts. So the enable pin is working. Yes, that is by design because of some diodes in the path there, Philip. Oh yeah, exactly, Johnny. Yeah. No, it's not. Okay, well, sure. I have some test points on the back, but I can't test on the ESP itself, can I now? Do I have enable labeled? Yeah, but it's in the wrong place, but it's okay. So let me find a ground. Yeah, so the enable pin is getting 3.3 volt. I can't check if the pin is connected correctly on the bottom of the ESP, but enable is 3.3 volt. I'm 100% certain of that. Frame drops. Oh no. Oh yeah, we got frame drops again. Not sure why. Well, yeah, but, you know, in the end, for production, these are actually pretty good to use. But, yeah, you know, they're what they are. What to do? I want to measure the connectors real quick. Just to be certain of something. And then we'll try replacing it again. So this shouldn't be anything. And this shouldn't be anything either. Yes. And this shouldn't be anything. Nope. Nope. Okay, that's good. No. We're just going to replace the module again. Don't worry about it. We can make it work. I'm not going to solder wires to the ESP. That wouldn't, you know, allow for any testing or prototyping action whatsoever. It's not... The idea isn't to make this work again. You know, I just also want to run other tests with it. And I'll blow something else up, and then I'll replace that. Yeah, I agree with that. Record vids. It's slightly tilted this way. But that's the problem of not getting enough heat in the board. Because it basically needs to float in place itself. But it's not doing so. But I think we cooked this one. Let me get another ESP. Where's my box? Let's see if we have more. I think we have more. Wait, what's this? Let's see. ESP32C3. Okay, that's with antenna connector. Don't have those. Nope. Ah, yes, yes. We've got more. You know, in the end, I'll build a new board at some point because I need it for other tests, but yeah, but I can't normal reflow it on the hot plate again. We know that. I'll make a new board at some point. I know, but yeah. So we got another ESP32. Yay! Okay, this one can go. Bye. Okay. Yeah, we're gonna take this one off. We're gonna put another one on there and see what that does. Luckily, all the other components around there are pretty heat tolerable. That's a word. Let's douse it in more flux. Because, you know, flux. Oh, wait, hold on. There. It's hard to do this and also show you. Sorry. Now I'm hoping we can get this one off and there will be enough solder on the pads to just leave it as is. Don't need to add any. Okay, let's give it a try. Okay. I nudged some components there, but those seem to have sprung back in place. That's good. The pads actually look nice, except for one. Yeah, sure, but I don't feel like trying more with this ESP. Okay. There, I wanted to remove that solder glob. Still a little bit there. Yeah, I don't know about the amount of solder, man. That's tough. That is tough to tell if that is enough solder or not. I think so. Yeah, there's not much on the pads in the middle. I mean, I can go over it again. I'm thinking, let me check the bottom side of the ESP. The one we just took off. Oh no, it's stuck to the towel. Hold on. No, don't do that. Yeah, so looking at this ESP, we can clearly see that the pads aren't soldered correctly. So I'm going to use a different method for that. I don't know about heat-wise, but let's try something. Okay, we're going to reuse this ESP real quick. And what I'm going to do is I'm going to make sure there's enough solder on all of the pads on both sides. So let's try and keep this on there. Oh. Okay. That should make sure there is solder on all the pads. Are some of them bridging, maybe? Ah. Hold on. Okay, those pads seem to need a little bit more. There. That looks good. Maybe a little bit too much, but... okay, that should be good. Okay, let's try and do it this way. Wow. That landed pretty good. Okay, that's already adhering. Oh. Yeah, since there's now solder on both sides, I'm not going to push it. But I do want it to align correctly. I'll hit it with some more flux. Okay, that looks better. Okay, let's leave it at that. What are we thinking about that alignment? Okay, I'll try and move it, but I don't want to nudge it. I think it looks good. Okay, components all look fair. 35% humidity. I'll just use the fan. That ESP looks so manhandled. Yeah, it's still warm. All my wires are crossed on my desk. Yeah, normally this will be put together by robots. And they certainly do a better job than I do. I just wish I hadn't killed the ESP itself, because that's the hardest to replace. You wish me the success now. Thanks there, Siegfried. Okay, let's cool the back a little bit. Okay. Yeah, I have to. But, you know, each time you learn. Okay. Let's see. Heat camera thingy. Let's just call it testing why it died. Okay, plugging it in. Oh, I'm seeing 0.5 watts now. I hear the USB sound. Oh, it's disconnecting from USB. That's good. Let me try and hold reset and boot. Yep, connected. I think. Oh no, it's repeating. Let me check what device manager is saying. Hold on. Reset. Boot mode. I have a USB connection. Okay, let's try and flash it. Hold on. I'll try and show you guys. One moment, please. Okay. Okay, so this is my test Home Assistant instance. So let's go to... oh, wait, no. I need to check if there's some passwords in there. Even if it's in the test, though, it shouldn't matter. But let me check real quick. Okay. That should be fine. So in ESP Home, I have my ESP32C3 configuration for this dimmer. It has the temperature sensor, the external temperature sensor, some buttons. I think I actually want to lower this because I was testing with a high frequency. Come on. I always need to look it up. Because I don't want to start with that high frequency yet. Okay. And then I just have the dimming channels defined. I have an RGBW light, blah, blah, blah. Right. So let's save, install, manual download, modern format. So we can get it compiled. And then you need to use the public website to flash it, because my testing instance doesn't have HTTPS. And they actually have a method for that now. So you say close, you go back to install, and you say manual download, like we just did. And you don't click on modern format, because we already did that. You go to ESP Home Web, and there you say connect. It gives me a pop-up. I can select COM4 there. And now I can just hit install, choose file, this one, and install. Erasing. Whoa. Is it time to crack open a can? Yes. Why am I using pin 8 and 9 on the C3? Why not? Yeah. Configuration configuration installed. Close. So now I should be able to go back to my Home Assistant and cancel out of this, cancel out of this, cancel out of this, and logs. And in theory, it should boot up. Uh-oh. Oh, wait, no, I have to reset it. I have to reset it. So hit the reset button. There we go. And it's booting. It's booting! Whoa! Oh no! It can't find my temperature sensor anymore. Is my temperature sensing getting power? Yes, it should be. Huh. Might not have all pins connected yet. One is boot and one is I2C. Well, I2C can go on any pin you want it to. Well, yeah, it'll always tell you about all kinds of pins, but doesn't mean they're correct for this ESP32 type. And doesn't mean you can't use them either. So, yeah. Okay, so the temperature sensor isn't working anymore. I guess we should check if the dimming is working, right? So I'm going to switch you guys back to the table here. I'm going to zoom you out. There. I need to go into Home Assistant, duplicate. Okay, so board is online. Pin 8 is always pin 8 on C3. Yeah, okay, but what does it matter? I mean, I don't understand. And everything was working, so including I2C, so that's not really an issue. And I did take boot pins into account. I did use the serial pins maybe, but I'm not going to use serial. So, okay. So now that we have this working, I'm going to connect 24 volts and see if it boots up correctly then. Let me turn that off. Okay. Yeah. Okay. And I'm using GPIO 9 as a button, I believe. GPIO 8 I don't know, and I know I have the pins correct. That's not a problem. Right, so let's turn 24 volt on and see what happens. Beam. Aw, we still don't have a blue LED. That's unexpected. Why don't we... We turned that one around, right? Anyway. Maybe I killed it. That's fine. So let me see if that boots back up. Yes, it does. Good. So now we're booted with 24 volts. And nothing is getting hot. That's good. I should have an LED strip here somewhere. Yep. So let me... I'm just going to run this off of the roll. So this output is 2 times positive. So let's connect that. And then we have a connector for warm white and cold white. Let's connect that. And then we have a connector for RGB. Okay, let's see. Keep the street. Okay, let's try channel 1. That's working. That's red. Channel 2. That's green. Channel 3. That's blue. Channel 4. That is cold white. And channel 5. And that is warm white. So at least the dimming functionality has been restored. There might be an issue with I2C. And... it might be some resistors that maybe got knocked out of place or something else. Or maybe I just fried the sensor. So let me disconnect it from power real quick. And I'm going to connect this external sensor, which I also have defined. Nope. It might be that that specific pin hasn't been connected right. Oh, that didn't go in right. There. Okay, that turned on. That's good. We can try and make pink in a minute. Waiting for it to boot up again. I guess I can show you there. Or maybe it was that external board that killed it. Could have been. Come on, come on, come on. Okay, no, nothing is heating up. But it's also taking a while to boot. Why? Okay, let's try and reset it. Okay. Okay, it's not booting anymore. Yeah, I'm pretty sure not all pins are soldered correctly. Let me try and boot it without that external board. Oh, okay, now it boots immediately. Interesting. Let's try it once more. Let's disconnect power. Let's make sure this is all aligned. Guess I could take the other side. There we go. Let's make sure this is connected right. Okay. Yeah, it worked fine before I killed it. But I killed it while that board was connected. So I'm thinking that board is toast. Yeah, doesn't boot. Not booting. Okay, so without that board... Yep, there it is. Okay, so... I was messing around with the cables last night, and I think some of the LED strip and this board touched the power supply on the wrong places. And that blew up my ESP, because there might have been 24 volt on that. So this one is toast at least. And that probably also explains why the onboard temperature sensor is also toast, because that was on the same I2C lines. And that in turn made it to the ESP32, C3 I think, and killed that. So I'm thinking it's probably soldered correctly. It's just that the temperature sensor is kaput. But I'm not going to bother too much with that. As long as this is working. So, yeah. So we wanted pink, right? Oh, we can check if the buttons are working. The button pins. So I have this little prepared connector with a single wire that goes in here. And then that is connected to ground and all the buttons are pulled up. So now we should see, yeah, button 3 is connected. Button 2 is connected. And button 1 is connected. And that's all hardware debounce, etc. So that's good. And if I go back here and to this one. Yeah, okay, let's turn white down. We wanted pink, right? Yeah. Well, how about this pink? How's that for pink, Johnny? Still got some pink tonight. So yeah, I think the ESP32 is soldered on well enough. I think we just blew up the I2C lines. And that's why I killed the other chip. And that's why this is now not working. That's fine. So this is actually one I use for testing, and I can put it on my fast random. Oh, that's a very fast random, and then it'll cycle colors every second. And then I basically just connect a bunch of LED strip and leave it running like that for 48 hours. And it already did that for like 30 hours or so, and then I started messing with it. So yeah. It's okay. But at least now I also know what kind of happened. So that there isn't really a design issue per se. But that I just killed it by touching a too high voltage at the point you shouldn't. Now I could add PTCs and diodes and things like that on the I2C lines. But at some point, you know, you just go too far. Cool. Well, that is the secret of the day. I'm working on a Quinled AN Mini prototype, which will be a tiny, well, tiny, it's not the tiniest, probably, but a small analog dimmer. It will do 5 channels. It has built-in fuse protection, all custom circuitry. It'll do about 10 to 15 amps if you wanted to. And it has support for up to 48 volt LED strips. Yeah, but in this case, Siegfried, we have an internal one that's likely shot and won't even be included on the production models. But I likely blew it up through using the quick port. Support for 0 gauge wire. No. Especially with 24 volt or a 48 volt LED strip. You don't need 0 gauge wire. Oh, you're working with 36 volt addressable LEDs? Well, my boards officially don't support that yet, the dig boards, but there is a board coming in the future which will support it. It's more in line of this kind of stuff than a dig board, but yeah. Cool. Yeah, I'm happy that's working. Let's turn it down a little bit in brightness. There, you can see the colors better. And I think that also kind of explains what happened, why it blew up. My PTCs are very big, yes. Later, Dave. And yeah, this kind of rework stuff is messy, as you can see. But we got it working. Oh, you're going back to China next week. Nice. I will be visiting Shenzhen somewhere in the next few months. I'm not sure when yet. I hope. Still need to look into it. Dutch Taurus, what do you mean total or per channel? He liked the unrehearsed nature. Yeah, this is trying stuff out. And, you know, I'm a bit more experienced with this stuff, but yeah. And in the end, yeah, the PTCs are this big because, well, I need to allow for 10 to 15 amps and up to 60 volts. So you need a really big PTC. I mean, there's a small PTC there, and there's a small PTC there, and, you know, but if you want to run a lot of current through a PTC and it needs to be high voltage, kind of stuck with that. I have not visited Shenzhen before, no. But I'm going with a mate of mine, and, well, I'm meeting up some people over there, but... A 24-volt AC relay? What do you mean with that? Worm, HA, and LED? The 60 volt will never be on the PTC? Yes, it will. Because the LED current and voltage is passing through the board, right? So... Sure, I'll try and remember Dutch Maker. Okay, but if I'm running a 48 volt LED strip and my positive voltage is traveling through this PTC to the LED strip, it's going to see 48 volts. Cool. Yeah, I know Dutch Maker. Well, let's check that. I don't agree there. So we have negative, right? And... Oh, wait, I'm holding my probes the wrong way around. Hold on. Negative. Oh, let's see here. Yep. That's 24 volt. And coming out of the PTC... That's also 24 volt. If I can keep it on there. Yeah, so there is 24 volt going through that PTC. What do you mean on PTC pins? Okay. Yeah, I'm not going to measure anything because it's positive to positive. Not quite sure what you mean, Siegfried. HVAC control for having Ecobee turn on and off central air need 24 volt AC for boiler hot water loops. Look into an SSR, Worm HA and LED. I have some on one of my pages. Hold on, let me look. Oh, come on. Worm and HA LED, check here. And at the bottom, there is there are SSRs, which you can, change with DC, and then connect AC if you want to. Yeah, exactly like Johnny says. I mean, there is 24 volt going from here to here through here. So in the end, you need to take into account the voltage that it can go through there. I'm confused what you mean. Cool. Okay, we're HA on LED. Yeah, I don't know, but it's in the case that one of the outputs is shorted, basically, that it won't draw unlimited current, and of course the power supply should trip on that, but especially the Chinese versions don't always. That's why I built some protection in my boards. If you reverse bias just the LED strip, nothing will happen, but it's for the case that there's a short there. Well, PC acts like a fuse, yeah. Maybe we'll continue this on the Discord server there, Siegfried, because I've been streaming about 3 hours now, so... Maybe I'm just not getting what you mean. Yeah, but this is all working, and I'm quite happy we got that repaired. Maybe I'll knock off the temperature sensor at some point and see if the external one is working again, but... yeah, you can do that, VinP, if you have a 48 volt central supply and then step it down to 24 or 12 volt, whatever you need. That's fine. But if you already have 24 volt LEDs, that's already pretty high voltage, so generally you should be able to run that directly. Actually, Johnny, if you screw up connecting the strip, nothing happens, because they're diodes. I can show you that. Are we going to show that? Yeah, let's show that. Let's connect this in reverse. See what happens. We just fixed it. So now we can break it again. Okay. It might blow up one of my MOSFET. No, it shouldn't actually, I think. Well, a 10 meter run, it'll depend on the amount of LEDs, or rather, the amount of power you're going to use. So let's disconnect this. Okay. Let's unscrew that. Let's put those over here. And now we're going to disconnect that one. Put the positive voltage in this terminal, which is connected to a MOSFET. And then put the negative side of the LED in this terminal, which is the positive terminal. Yeah, if you have a solder bridge, that's why the PTCs are there. Because in this case, I don't think anything will happen, actually. But we can try it. Let's try it. So now we have the positive in a MOSFET output, and we have the negative in the positive output. We're going to put our glasses on, because, you know. Exactly, nothing should happen. So let's get the thermal camera out. And boom. Let's do it. Okay, well, it turned on. I don't know if the LED channels are currently on. Oh yeah, it's still cycling, so it'll hit that channel. Yep, it was on. Yeah, nothing happens. That's fine. But they're there in the case that there's an actual short or something like that, that it won't be an unlimited short. Because I've been testing, and if I blow up one of the MOSFETs, it'll dead short. So the MOSFET will be fully open, and then it'll allow, like, 40 amps to flow through, which we don't want. And then the PTC will cut it off. That I know works. I mean, I've tested that already. So yeah. So let's reconnect this and make it work again. Now, if I short it, I blow up a MOSFET. That would give us magic smoke, yes. But then I'd have to rework the board again, and there's some other tests I want to do first. So I'd rather not right now. Oh, okay. These new... I didn't even screw it in. That's bad. These new onderzetters, I don't like them. They're from the IKEA like I had before, but they're not as good. Okay. Let's connect this one. There, it already works. Oh. That's what I hate about these rising clamp connector things. You think you're screwing it in, but you're actually not. Let's see if the other channel still works. I'm using N-channel MOSFETs, so I'm PWMing ground. Yeah, VCC is connected directly, well, through the PTC. And then ground is PWM'd. Oh, stupid connectors. There we go. There, and we have 2 colors of white again. Oh, we can just plug in RGB too. RGB go! There we go. Yeah, I know, but this was just a little test strip, so. I have another strip here, which I also used to test with. Which is under my crimper and cables now. Oh no. Okay, let me try and get that. Holy shit. Okay, one moment please. That crimper is so heavy. Okay. Okay. Yes. I need to correct some wires here, and then I can show you my other testing strips. Okay. This is a GRI RGB plus CCT, or rather plus CW and WW. So RGB is one chip, and then you have a warm chip and a cold chip, because the warm white and the cold white are CRI 95-ish, and then you have an RGB chip. Yeah, and they're on my analog pages. If you look for RGB CCT, you should find it. And they're decent. They don't produce a huge amount of light. It's respectable. but they are a good quality white instead of a bad quality white. Okay, let's disconnect this. So from everyone who's still here, do you guys like these pluggable style connectors or not? I like using them, especially if I'm going to be using a case. Yeah, I'm wondering what you guys think. Five meters of the high power 2835, a 48 volt, but those strips are 24 volt, right? Or do you have a 48 volt variant there, VinP? Right. So let me turn the studio lights down, and then we can enjoy the show. Where is my HA? Okay, let's go here. Hold on. Ah. Okay, whatever. Turn this off, turn this off, turn this off. Yes, now it's dark. Let's crank this up to 1000%. There we go. So these are some other testing strips I have. I'll try and show them over here. These are actually cob LED. So there's a cob LED CCT. As you can see, it lighting up in two different white colors. And then there's a cob LED RGB. These are both from BDF Lighting. And, well, I have them strung around in my room here. Let me see if I can get the other end. So, yeah, these are pretty nice. Let me turn that down so you can actually see something. There, now you can see the colors. These are pretty nice. They produce really vibrant colors, and they produce a decent enough white that I'd recommend them. So yeah, I like those. And it's just running through my testing pattern. I can't see what chat is saying. One moment, please. Oh, you'll drop down to 24 volt. Yeah, okay. You use those with a lever. Yeah, I kind of still like screw terminals, because that generally works best with ferrules and bare wires and stuff like that. And I like using ferrules like these have, but not everyone does, so. Phoenix Contact LPC, okay. But how much do they cost? That's always a thing. Because if it's like $2 per connector, yeah, that's not going to work. Yeah, I know those two. I don't like using those with ferrules. But since this is a pluggable style anyway, you could still use these if you wanted to with the current design. Yeah, just get... I know, but... That's what I do with mine too, but, you know. I think I still like the screw terminals. I do make sure to include Phillips heads instead of flat heads, because I don't like flat heads, but yeah. Let's get some light in here. There, that's fine for now. It's funny that that little strip can light up the whole room. It's not drawing that much power though. 70 watts, 50 watts, 80 watts. But that's basically why I do my test pattern here and have it looping for 24 hours. It goes between 7 and 100 watts and it changes each second, so... If there's a torture test, that is one of them. Cool. Well, with that, we've easily reached 3 hours. So we did a lot of stuff today. we crimped this behemoth of a connection cable. We don't need that for these LEDs, luckily. But yeah, this is 50mm square or 0 gauge connected to 2 Anderson plugs, and in the end the result is okay, I'd say. Yes, it can be better. Yes, I know. But I think this new crimper is already a lot better than the old hexagonal style one that did work great for the lugs. Because I'm also going to be using a lot of lugs. Like each battery will have several lugs on them, etc. And circuit breakers and things like that. So that's good. But I like using... I want to use these plugs, basically. So I think now we can. I mean, right? And this is a little testing cable, but yeah. It was very nice to watch you struggling. Thanks. Hey, if you do this yourself, you know how it works. It's, you just keep trying, and at some point you'll make it work. And you get better at it over time, but people always think like I have some kind of mad soldering skills or things like that. I don't. I'm just, I'm okay. I'm not bad. There's 2 resistors here, and I really wonder where they're from. I'm just going to throw them away. I'm not bad at soldering. I'm not the best at soldering either. I mean, there's certainly people I know that are better at it. But I can make it work, and I can work with 0402 and build a board like this in my garage and have it work perfectly fine until I blow it up. But yeah, I mean, we do what we can do. It's so nice, not only me. Yeah, that's exactly why I do these live streams there, Siegfried. Videos, especially from some channels, always show like it's gonna go perfect every single time. That's just not reality. It's not gonna go perfect every single time. You're gonna burn up components. You're gonna burn up boards. You're gonna make the black smudge escape from the PCB material. You're gonna, I don't know, create a lot of smoke, blow up stuff, cross wire it, design it wrong. You're gonna do all those things. That's just the reality of it. And yeah, that's fine. As long as you learn from the mistakes and figure out what went wrong, I think that's fine. Just trying to get this stuff back in its baggies here. And hey, nowadays when I solder something like this together, generally can make it work the first try. But that's just experience and that I've done it a lot more, and I know my own designs and I know how to make them solder correctly and things like that. So you might burn up your house. Nah. I try to avoid that one, Johnny. But I think it's important, especially in live streams like this, to show reality instead of perfectly prepared, it'll work every time stuff. We have videos for that. I mean, you're just here for the magic smoke. Well, we had a lot of smoke today. It was all flux smoke, but still, there was plenty of smoke. Yeah, exactly, Siegfried. Easy looking, yeah. Maybe. And maybe it's easy for them. I don't know. Maybe I'm just not good at it. I feel I'm okay. I have a fairly steady hand. That helps. But doing things on camera always adds another level of complexity. But you know how it is. Always use a Lewis amount of flux. Yeah. How your wife, girlfriend think about your projects? She likes them. They bring in a little bit of money and stuff like that too, so she's okay with that. Yeah, I don't like doing that. I will prepare better for a video demonstration, etc. But not for a live stream. Yeah, in the analog. Oh, these I don't think these are on my website yet. because I'm officially, I think, still testing them, I guess. But if you look at BTF lighting, they have 840 LEDs per meter RGB, and I don't think it's 840 RGB LEDs a meter CCT. But BTF lighting has these on AliExpress at least, and they are the non-addressable kind. You can also get the addressable kind, but yeah, these are analog versions. So yeah. You need to have a fire extinguisher nearby. Well, I have this here. Fire stop! Oh wait, other way around. Fire stop! I hope it'll do what it says on the can. I don't know, I've never used it. So yeah, it's pretty close. You recently tested 5-volt LED strip with up to 25 volt. Yeah, that's gonna. I've done that before. And you hear like on the LED strip, you hear all the little controller chips blowing. I've done that before. You should run a test on that fire stop. Yeah, maybe when I build an outside streaming setup, but not while I'm in here. Cool. Well, thanks for the comments there, Siegfried. I actually don't mind discussion. We don't always have to agree in things. But I do, I actually appreciate discussion in that sense. And I'd rather have someone who's, goes against me or has its own opinion than always says, I agree with you. So I admire that. Thank you very much. Are you on the Discord server? If not, please join. It's always fun hanging around there. Yeah. I value good discussions. Oh, it's still working? Built the resistors? Wow, okay. A fire stop potential on camp zone. I don't know. I'd have to discuss that with some other people too. Cool, yeah, but I'm working on some stuff. And this is one of them, this analog board. I'm working on some other analog boards too, and I'm hoping to have those available pretty soon. So that every time I have to recommend something analog PWM, I can recommend one of my own boards. I have DIY designs, of course, but I can recommend a pre-produced module that works well, in my opinion. Now, click like. Yes, please. Because I'm going to go. It is now 3 hours and 14 minutes that I've been, well, kind of streaming, so... Time for some Easter eggs. No. You already had so many secrets. You had the begin... Sorry about that. You had the pre-stream secret, and now you have the after the main event secret, which we worked on for like 1.5 hours. But we got it working. So that's enough secrets for today. Any idea when the Dig Uno will be in stock for shipping to the UK? We're reproducing right now. We kind of ran out quicker than we thought, so we got struck by Chinese New Year. They are in production right now, so they should be available in a few weeks, I hope. And then we'll have plenty of stock again. You want the ultimate desk project secret? Well, if you watched the Quinboxed emergency of the ZKE-Tech tester, you might have seen the desk there. So maybe look that up. Okay, guys, I thank you all for watching. It was a fun stream, and, well, I did something I needed to do anyway. Got the board working again. So thanks for hanging out, and I'll see you guys later. Bye-bye.
There is something so wrong, and lately I don't know what to do. Picture perfect, but I'm dying, and I know you feel it too. Why not we both get so still? Tell me something real. I need an adrenaline shot. Make me feel what I forgot. Baby, grab the wheel. We are road warriors, free and notorious. Shut up and drive. Ride or die till the end. For it, kiss me again. Shut up and drive. Shut up and drive. Shut up and drive. Shut up and drive. You and I, just shut up and drive. No